good to see you all again. So today we're going to have Toby talking about Desmos, and then hopefully we're going to have Mitchell talking about Gödel's incompleteness theorem. Whether or not Mitchell arrives, there will be pizza. Yeah, take it away.
Alright. Hello everyone, my name is Toby. A little bit about me. I'm in my first year of a mathematics degree, intending to major in pure maths. And ironically, I'm actually not a programmer. As in, like, I'm not fluent in any programming language except Desmos. Some of you might say, but Desmos is not a programming language. And to that, I say, again, I don't know enough about programming to deny your question. But you can definitely use it like a programming language, at least to a certain extent. As you might have guessed, I like to do stuff in Desmos. So here's a few examples of that stuff. Here is a fully working remake of Minesweeper. And you can even die. It's a 3D projection of a 4D hypercube with the 4D rotations. That's really nice to watch. I better get off this before it gets too distracting. And a mostly finished remake of Tetris. It would be fully finished, but I was too lazy to finish it off. Anyway, those are just some of the things that you can make with Desmos, and if you've ever seen the extent of what some other people can make, you know that that's barely even scratching the surface. Okay, so we've established that you can do stuff in Desmos, but what is stuff, and how? And isn't this just a graphing calculator, and a 2D one, and it'll get 3D graphs of 4D hypercubes? And what can't you do on Desmos? Well, yes, it is a graphing calculator, so let's start there and see if we can build our way up to hypercubes then and Doom. So as a graphing calculator, it follows that most people's knowledge is that you can graph functions. You might also know that you can graph points, and there'll be a point on the graph, and you can also define conditions for functions, which can be useful for piecewise. So I can say, add the curly brackets and say x is greater than 0, and now we get this function only when x is greater than 0. Makes sense? A lot of people also know you can have variables, and then you can have a slider that increases that variable. You can also define a variable as a point, and then that will let you drag it around. And then you can also get the x and y coordinates of that point. So that can be useful if we do something like this, where f of x, and then subtract the x coordinate of that point, and then add the y coordinate. We now have that green graph translated by the red one. You can also define points in terms of variables. So I can define this point with cos of t and then sine of t. And now that point will just rotate in a circle as t increases. And then also points on Desmos are basically just vectors. So you can add them in the exact same way that you would add vectors. So here, A and B just add together like that. And then you can also multiply them as scalar by a scalar in the exact same way as well. Okay, so that's enough for the very basics of what most people know you can do. So what more can we do with that? What is not a built-in feature on Desmos that we can do with what we have already here? So one example of that is complex numbers. Complex numbers are not built into Desmos, but we can kind of make them ourselves. If we pretend the x coordinate of this point is the real component and the y coordinate is the imaginary component, so basically exactly how it is on the complex plane, then we can add a function that takes in two points as inputs and then multiplies them using the rules for complex multiplication. And then we can have the product at that point and then watch how the product changes as these two variables change. And using a few more functions and some willpower, you can eventually get one number raised to the power of another complex number. And so I can change these and see how the purple dot is the product, and the orange dot is the red one raised to the power of the blue one. And a very interesting shape as you change them around. But this is really good for intuition on complex numbers, because otherwise you can't really see how multiplying complex numbers work, apart from just seeing the two example points and then the resultant. So having that interactivity is really good with that for actual, mathematical purposes. And this is a bit of a recurring theme on Desmos. When you don't have a built-in function, you can make the things that you need in order to make whatever you want to do. And before we go a bit further, I'm going to introduce another few basic features. So you can define custom colors using RGB or HSV, and you can define polygons using any number of points. So I can make a polygon between A, B, and the origin. Oh. And then now I get that triangle there, and then I can color it using the custom coloring page. There. And the reason I'm showing you guys this now is because sometimes I'll be showing some of my friends something that I'm quite proud of, like my 3D complex demo function.
Wow.
And then they'll say, "Oh wow, how'd you make it rainbow?" And like, I agree, it looks nice, but that was not the hard part. Anyway, going on to the next feature, that I might turn these off so it's not as distracting having this point go around in a circle. The next feature that is still quite useful for graphing is lists. So lists work very similarly to how they do in regular programming languages. So you use square brackets to define them, and then you can either define a list by typing off all the elements, or you can define it with equally spaced numbers. So if I do 1.20, we get all the integers from 1 to 20. And then if I space this and do 1,3,20, we get all the odd numbers. And note how the last number there, 21, is larger than the 20. It's just how it works in Desmos.
A quick question.
Yep.
Does Desmos support unbounded lists?
In a way, not with this list here. So the maximum value of lists is 10,000.
The maximum length or maximum value?
Oh, maximum length.
Okay.
So the maximum number of elements is 10,000.
Yep. Okay.
Which will be unfortunate sometimes, but you're doing stuff in Desmos, you're going to have limitations.
Fair enough. Thank you.
Yeah, and so with lists, we can multiply them similarly to how you can with points, and you'll multiply each component individually, and you can also add a number, and that'll add that number to every single point, or to every single element in the list. And so one interesting thing with lists is you can get some very interesting shapes when you combine it with points. So if I make a circle that rotates exactly as I did before, I can then say, if I instead of wanting just one point, I want a big long arm of points, so a circle with radius 1, then a circle with radius 2 as well. We can multiply this point by our list, and so now we have a bunch of points of different radii moving in a circle, which is not that interesting. This is just a clock arm. But what you can do is you can change the speed based on the radius. So I can multiply the speed by if I slow that one back down a bit, we get some very interesting shapes. And this is also very hypnotizing to watch. But the way combining lists like this work in Desmos is that it'll just do it element-wise. So we have the point at radius 1 has a speed of 1, and then the point at radius 2 has a speed twice that of the first one. And then I'll just pause this again, so not to get too distracted. And something interesting actually, if we set this to exactly 2 pi times the golden ratio, we get a very nicely evenly spread of points, which is one of the actual properties of the golden ratio, and not the damn rectangle and spiral that people overlay onto anything. And with lists, we can also take a slice of them. So if I make these points, if I want only the 55th point, we can just type 55 with the square brackets like that. And if I want the 55th and the 110th, I can do that. If I want every point from 55 to 110, I can do that. So that all works in the exact same way where you adding a condition with another list. And you can add regular conditions as well. So if I only want the points on this where the x-coordinate is greater than 500, I can put our formula for the x-coordinate of our points, and I can say that is greater than 500. So now we only get these points based on this condition that we've added. Another thing I can do, if I want every 34th point, I can say mod of L, 34 equals 0. Now we get one spiral there. If instead of 0 we had 13, we get the very next spiral over, and you might notice that those are Fibonacci numbers with 34 and 13. And that's another place where the golden ratio and Fibonacci stuff is actually present in this kind of construction. But again, at the start of this talk, I promised that you could make games. I showed you Minesweeper and whatever other one I showed you, I forgot, Tetris. And so to do that, I'll show you the next major feature of Desmos, which is actions. So I can define a variable x here, and then I can have an action with x goes to x plus 1. And so now whenever I activate this action, x increases by 1. And another thing I can do is I can put this action in something called the ticker, which is just a permanent loop. So now I activate this, and x will just increase as fast as Desmos will allow it. Another thing, you can name actions, and so I can put this name here in the ticker instead of running it myself, and then that's good for compactness. And then one final thing, I can also do functions with actions, and so now I can iterate it by 2 every time. And you can't quite tell because it's going so fast, but you get the idea. Another thing you can do, okay, so let's investigate how we can actually make games with actions like that. So I've pre-built a little, if I go back here, a little physics simulation here, which is another thing, by the way, I forgot to mention. Another thing that's useful with actions is simulations. Like, I'll actually just pause for a bit, is you can do simulations which, like, for physics or probability simulations. So if you have a differential equation, you can, use your favorite numerical integration method and then plug that into an action that runs in the ticker and watch how that evolves. But, we care about games. Right. So what I can do is I've already made this point, and I've got a main function that runs in the ticker, which will have the point fall with gravity and also go to the right by a little bit. Did you have a question?
Is that comma there just do this action, then this?
I will get to that. Somewhere. I don't know where I've got that. But yeah. So we've got the main, which just increases and falls, and this is not that interesting right now. But what we can do is we can kind of implement a little bit of a jump for this, imaginary game, where we want to have some user input. So let's add an action where the user can click, and this plane will kind of jump along. So let's have an action where the velocity of our particle goes to the x velocity, the x velocity, and then sets the y velocity to just 4, so it kind of just jumps up. And so now when I run this, I can click this, and it'll just bounce along like that. Then if I add an image to it with some rotation, you can probably see where I'm going with this. You can get a little bit of a Flappy Bird here. But again, this is just the mechanics of the game. This still kind of sucks. We don't actually have anything. We can click and we can jump. Big deal. What else? So what we can do is add conditions on actions. So if I have some variable y, I can say, instead of just doing y goes to y plus 1 and increase that, every time we click that it increases, I can use the piecewise curly bracket to say, if y is less than 5, then y goes to y plus 1. So we've essentially got if statements now. So now I click this, and y will increase, but now that y is no longer less than 5, it does not do this action anymore. You can also have else statements by having a comma, and then I can say y goes to negative y. Now I click this, and y will become negative 5. And then I click it, and it'll go up, and then negative 5. And so let's use that to add some collision to our game, just with the floor. So let's say we'll run the main if the y-coordinate of the bird is greater than 0. Otherwise, we'll just reset it. And so now, I can click this. If I don't click it, we'll die. And if I click it, we'll have a little bit of a game there. Another thing you can do with actions is you can put them on a polygon. So I can make this polygon say it's clickable and then add this action here. So now, whenever I click this polygon here, it will do the action. This makes it a lot easier to have actually in-depth games because you don't have to fiddle around with the sidebar and it'll just be awful. And then, you know, just add the pipes, add collision with the pipes, add a little bit of flourish, and then you can have a fully working version of it. No. Yeah. This is not too late. But okay, I think we're finally done with a lot of the stuff that you can do with Desmos. There's a few features I haven't touched on yet, which depending on time I might get to. But why? Like, why do I do this? What is the point? If I got a Python and actually spent like an afternoon properly learning how to do whichever specific thing I could do, I could easily make, you know, a 3D grapher or just put this grapher into a pre-built software. Or, you know, make a version of Minesweeper that... Well, this one isn't actually that bad. But why do I do it? Well, for me, it started with a bit of unquenched curiosity, where I was just wondering, I wonder how far I can go with stuff in Desmos. And then I learned about a new feature, and I was like, I wonder how far I can go with that feature specifically. And then once I built some of the stuff and built the stuff in place, I was like, well, this is just funny now. This is just funny to make awful things in Desmos. But because, another thing with that is, I'm a bit lazy. Like, if I made Minesweeper in a regular programming language, no one would care. And I also wouldn't care, because it's not going to be that hard to make, and it's not going to be that fun to play compared to regular Minesweeper. But doing it in, you know, this convoluted area where you have restrictions on what you're able to do makes it more enjoyable for the problem solving of how you can get from the base of just a graphing calculator to an actual finished product. So with that, let's look at some of the limitations. One of the big ones is that you can't have lists inside of lists, which is really annoying for 3D stuff. So you have to define a different list for each of the coordinates instead of having one list where each element has a list of each of the coordinates. Another limitation is that you can only have this one main loop where you can't have any base for loops in it, and then everything in that loop runs at the exact same time. So if this was a regular Python thing, it'd just be the main loop with a bunch of if statements for each variable. This is probably not a good example, it's a bit small. But it's just one main loop and then if statement for each variable to update that depending on conditions. You can go pretty far with it, obviously, but I'm not sure on the specific limitations because, again, I am not a programmer. We do have a bit of time, so I'll take some questions and I might introduce some other features that I haven't shown and some other examples of stuff. So does anyone have questions?
Have you
Sorry.
have you personally tried adding sound effects using the thing where you can like hear the graph?
I have not. I think there's also a more recent sound feature that I haven't looked at. But I've seen some of the sounds that people can make, and I've tried to experiment with making sounds by having, because it's all based on tones. But again, I'm not much of a music guy either.
Can you have lists of anything other than numbers?
You can have, yes, that's a good point. You can have lists of numbers or lists of points. You can only define lists sequentially with numbers, but then as you saw back here, we have the list of all these points. And then, yeah, you can also define a list yourself with points. So I can say 1, 2, 2, 1, 2, 3, whatever.
In a similar way, could you make lists of polygons?
There are ways. So I have one example. I'll just go through some of the examples to showcase stuff. If I go to, oh yeah, I should probably mention this. A very mid but functional version
No
of it.
way.
Oh, so can you have hover then?
Sorry, say again?
Sorry, so like when you're just hovering your mouse over to change direction?
So what I've got here is I've got some invisible polygons on the right with actions on that, and then the image in the middle also has an action on it. Another thing I should have mentioned is that another limitation is that there's no good way to do game input apart from clicking. You can kind of do keyboard input, which is what this was kind of to experiment with, but it kind of sucks because you can't hold down W and go forward. You have to click W every time you go forward. And you also notice that if you've ever actually seen the original Doom, it is quite good. And this is a... you know, if you might have noticed that the demons here will either just immediately appear behind a wall or be completely obscured, and that's because they're just represented as points that have an image on them. Points that have an image on top of them, which that image is then either opaque or completely clear, depending on if there's a line of sight to them. But yes, with a list of polygons, I have something here about integration, where I've got something to like represent Riemann sums, and then so you can kind of have a big list of points like that. Also, a project I was going to show middle of the talk, but I forgot to open up, where I was explaining the purposes of actions and how that can be useful, is you can have, with direct differential equations, here's the Lorentz system, which is a set of 3 differential equations, and then I've used a very basic numerical integration method to get a very rough approximation, but it's very nice to look at. Anyway, anyone else have other questions?
So this isn't really a question, just a comment. I think this is fantastic. This is like looking at myself 9 years ago, right? I don't know if you heard me talking about graph in the math space,
Yeah.
but this is exactly that sort of shit. So
Yeah.
we should definitely talk later because, yeah, there's like there's stuff that maybe you know all this, but
Yes,
there's
I do remember you saying that you spent every day in high school on
yeah,
graph.
pretty much. So yeah, this is like
Yeah.
this is great. I love this.
I did a very similar thing, every day in high school. And if I had a topic that interests me, because like the maths, in high school, it's not that hard, especially if you're actually interested in math and looking to do a math degree. So whenever I wanted to do something that interests me, I just boot up a Desmos file and investigate that a bunch.
Yeah, let's talk later.
Yeah.
I love it.
Very, very glad to hear that.
Are you excited about Desmos 3D coming?
Honestly, to be honest, there's not as much interaction that you can do, and I already had a 3D grapher.
So does it not?
Which is now
it doesn't have built-in native.
There's a
It
reason.
has a beta, yeah.
Yeah, there's
Yeah,
a
it's in a
reason.
beta, it's been around.
Desmos 3D.
But those demos you were showing before was technically in a 2D
Yes.
rendering.
Yes, and so this was my own custom rendering.
That's just really.
Yeah, I think there's a part of the script that I completely skipped over, but you just have 3 lists that represent the x, y, and z coordinates, and then you have a function that takes in those 3 coordinates and then spits out 1 point based on a bunch of 3D rotation matrices.
Yeah, sure. You got to do a projection, though.
Yeah, and you divide by the new z coordinate. Nice. Any other questions?
Just quickly, how are you handling the opacity in the 3D rendering there? Is there any kind of priority, or is it?
Yes, so by itself, polygons will be not fully opaque, so they'll have opacity built into them. And then originally I had this as all one solid color, but then I found that it was a lot more interesting to have it rainbow. But a problem I face with that is that sometimes you get the ones that are further away being shown in front. So I've just also got a little bit of a sorting algorithm to make the ones in front render first.
Brilliant.
Yeah. Alright, does anyone have other questions?
You probably explained it already, but how does it deal with, like, can you make new lines or whatever just pop up at any time? Like, could you make like a drawing tool where you can see like lines and stuff like pop up in real time?
There you go.
He's like, I've done this already.
Using Bezier curves, you can use
Wow.
define these 4 points. The reason I did this is because I kept seeing people who would do a bunch of equations to make art, and I was like, well, that's just brute forcing it. And I just made this tool, and then you can just put an image on, and then trace over it, hide the image, and then you have a 10-minute quick picture of a skull. And you also you can change this time, and because the Bezier curves are based on a parametric equation, you just let t increase up.
Wow.
Would there be a way
Can you
to...
go back to the drawing tool?
Yes.
What actually was the action that you used to create the line itself?
Yeah, so I've got Yeah, so I guess I should probably mention some of the other features I haven't talked about. So one really useful thing, I haven't mentioned any of the features of how you can integrate lists with actions. So there's a lot of built-in features with lists that will either take them to another list or to one number. So if I have some list like 1, 2, 3, 7, 12, 5, and I call this M, then you can take the average. I guess it's mean of M. There's a bunch of other ones, but one really useful one is join. So I can join M with 1, and I get a new list that has this appended on the end. And I can join with another list, and I'll get that. So what I've got here, if I can remember how I did it, this dot adds all these points to a list of the points, which then is all displayed at some point. This was a bit of a while ago, so I can't fully remember the specifics of how I did everything with it. But yeah, this is join is a really useful one. So whenever you, especially when I was talking about probability simulations, you can't really do it that well unless you have some list of all the prior examples, and then you join that list with a new the new results for whatever next trial was. Any other questions? I think we still have a few minutes if anyone wants to ask anything more.
Yeah, okay. I'm aware that I'm evil for asking a first to this, so I'm sorry, but everyone's thinking it probably. Do we know if Desmos is true and complete?
I heard someone talking about that in the other room, but maybe.
Yeah. I mean, I'm a little encouraged by seeing Minesweeper there, because I've heard something about Minesweeper being true and complete, but I'm not sure the context under which it is. So we should probably look into that.
I could have looked into that.
It's looking suspicious.
Infinite size Minesweeper is true. Infinite size Minesweeper is true. If you can make an unbounded size Minesweeper, you do not.
It's just program.
Yeah, the thing is you do have the maximum list.
Yeah, but practically any computer can't really.
Oh my goodness.
What happens?
Yes.
This is zooming in.
Wow.
As it goes around. I watched the three blue, one brown video on Fourier series, and then
did this.
Spend a bit of just fiddling with numbers, and then you get, with even just the basic intuition of a really good 3 blue, 1 brown video, fiddling with yourself makes it so much easier to understand the maths a bit more. So even though I couldn't apply Fourier series for any practical applications, I can do it in this case. Let me just go back to this whole thing.
I need to find my
I do have regular things that I probably should have had already expected instead of having SpongeBob. But I think this was one of my very first Desmos projects, was making art of that, so it's a bit iconic. Okay.
One quick question: how are you getting the SV? How are you storing the data for the curves? Is it
it is quite reminiscent of how actual Fourier series work, but I've got the this is the list of, if I change this one of the other ones, this is a big list of all the complex coefficients of each for the complex Fourier series, and then I've got a function, but this is them in polar form. Then I've got a function that turns those, and then just, each of these is now a complex number being added with rules for complex numbers. Yeah. Alright.
If I can build onto that, how did you figure out the said precise frequencies that you needed?
Yes. So originally, I just built in the one that takes the coefficients and then creates this display of the Fourier series.
Yep.
And I was just using that by getting an SVG, putting the points on it, and putting it into some website that takes the SVG path and creates the, basically I had a bunch of other programs that found the numbers for me.
Right. Okay.
Eventually I was like, I could do that myself in Desmos. So I made a different one that will run this, so I have any path, and this, each time it does this, it generates a new coefficient. Each time it runs this tick. And then that original one, if I open this up again, this original one is the path that the points will trace, or that the, whatever they're called, epicyclers or something, will trace, defined as a kind of parametric curve, except because there's no easy parametric curve for this, we have it ourselves, and then we do the integration with the discrete points or whatever it is. Again, I'm not quite an expert on this stuff.
Thank you.
Alright. Again, I ran out of words to say from my script a long time ago.